You're live. Is this working? I always need to find out. Testing, 1, 2. Yes, it's working. Okay. Hello, everyone. Whenever I can, my live update, unedited, raw, on the spot, which is becoming a nightly thing whenever I can, anyways. So, even if I don't have much to share, I figure I might as well go live and speak what my thoughts are, anyways. Um, Tonight, not much things going on. Still exploring the quantum power cells, and I heard back from somebody who's experimenting with it. Freedom Fighter, I believe his nickname is, from above unity.com. I'm sorry if I've got that wrong, but it's another pretty interesting form, and he experimented with it, and very interesting and success and good stuff going on there. I like to see that other people are progressing with this as well and making their own observations that line up with what I did, like the piezoelectric properties. They are reactive to heat. In part, I have an answer to that. What happens is when you heat it up, even with your hand, like if I take one of these cells here and hold it on for a few moments like this and introduce heat in the solid state electrolyte, they're very heat sensitive. You only put them in the oven at like keep warm for a few minutes, and this becomes like a wax-like substance. And what I notice is when it becomes back to its fluid source, it becomes more temporarily conductive. So it enhances for that moment the potential output, which is quite interesting because you're doing it without actually adding any moisture. It's just becoming more of a liquid form, and that true conductive or in other indirect methods enhances for that moment. Very similar to when I put it in the oven and then take a reading without conditioning it, and the voltage goes up, and I let it dry, and then it stays like that for a while. So yeah, that's another way of doing the conditioning. I also noticed that take one of these cells here, and you simply breathe on them like that, take a reading, and the voltage goes up a couple hundred millivolts. So, yeah, by doing that, I mean, don't try and, fog it up and create condensation, because then it becomes just a normal wet cell. But just, putting wind on there, essentially, I can go like this and add some wind on there. And it's so sensitive. Everything seems, as others have noted, fluctuates the voltage from these cells. Very interesting behaviors indeed. So more study to be done in that. So let's see if anyone here is watching. I'm going to turn around here, my little administrative window. And we have 3 people. Hey, hello everyone. Hope all is well. So tonight, I did this the other day, but I started binding some of my research, so this one's getting pretty thick. Physics of electromagnetic waves. Really good stuff. Notes, observations. Space-time and gravity. Segment of the tri-space universe. All kinds of space-time and mass effects on inertia. Some math stuff as well. Try and plug it in with the Maxwell sometimes, The speed of gravity and gravity waves. All the formulas here. A lot of these I already have on my Maxwell wiki, by the way. Some references to the publications, the role of gravity in quantum theory, for example, May 66, that's an old one. But yeah, I've got all of the references to the notes, and I have that excerpt, that exempt uh, from Tom Bearden that he was talking about, that book of magnetic anomalies. So I printed that out with all of the. It's very, very old book, but they actually give you all of. Tom Bearden got his um, some of the ideas on making his meg from this, and it's kind of funny. It's really old-fashioned, but it gives you, as you can see, all the information along with like the Floyd Sweet stuff. So a lot of the roots of the Tom Bearden stuff actually all comes from this one book here that he was referring to, which gives you like diagrams and at the time circuit diagrams of how to actually explore these various magnetic anomalies that he was talking about. So at least I printed that out for reference. Sometimes, it's easier for me in that form than having it all as a PDF. I get headaches, and the brightness of the screen or the way I always have to hold the tablet with this is just, I don't know. I guess I'm just old fashioned that way. I can assimilate better in book form. So there we have it. So like I said yesterday, I did my Maxwell wiki, which is I'm pretty surprised at how thick it actually, once it's all printed out. All the calculations here and the math. Nathan Stumblefield. Magnetic dipoles in the Dirac Sea. All good stuff, for sure. Let's see who's on. Hello, everyone, once again. Yeah, it's really interesting stuff. Yeah, the gravity, is a wave, right? And it's all frequencies. So it's very relevant to the alternative energy field. As I was explaining yesterday, exploring these frontiers, we'll just call it, gives insight and more hints on, the free energy stuff in the sense of manipulating with external systems that we don't have to pay for. I always have to specify when I say free energy because the trolls will all come at me, right? There's no such thing as free energy. What are you talking about? And we all know what I mean. Free energy, as in, it's the environment that we can tap into. We don't have to pay $1 for it. But yes, we still have to pay for the Tesla coil-like device that I built to tap into it. The initial cost, the maintenance cost, which could be a very fraction of the actual cost of actually paying out of your pocket as a watts value, right? But the mainstream, they have such a hard time understanding that concept and how, in many ways, there are already natural green energy sources, as bad as they're killing the whales by the sea, the windmills and whatnot. That is a source of free energy. Maybe if they would move them away from the sea, it would be better, but still not the solution because it's only windy part of the time. Same thing with solar, right? But, it's a step in the right direction, obviously, but it's not the solution. I think they're trying to make, there's political agenda behind it and lobbying and the companies that make these panels and get the contracts on the windmills. They blow it in the frame of, green energy. So anybody who disputes it is anti-science and they're racist and everything. I don't understand it. I try and stay away from the politics because I've got enough dealing with the trolls, So, but yeah, I mean, I personally think they should be exploring concepts like the one wire system. Use it, a big central power source at high frequency, feed maybe 100 kV through the one wire system. Have one wire taps. Every power supply is basically a reactive supply. Every tap is locally, it's a reactive instead of a power traditional transformer would be a reactive stage. And it's reactive current power that would actually feed everyone triggered by the one wire system. but very minimal loss. Great. Tesla was onto it. They stopped that because they couldn't meter it in traditional ways anymore. But if they're really serious about green energy and saving the planet, how about making it so the power plant doesn't have to cause all those pollutants? You'd still have to probably burn fossil fuels, but 1/10 of what we're doing now. As Tom Bearden says, there's no free lunch, but we can have a big buffet if we know what we're doing. So that's why I don't like it. I think it's a scam, but yet they tell us, shut up and eat their free energy agenda. If they really cared, they'd be exploring the topics we do: Bedini-like devices, reactive systems, Don Smith, magnetics, Howard Johnson stuff with permanent magnets. As crude as it is, it worked. Why not? So if you don't know, I go over here. This is kind of like my live laptop here, so I see the chat from here, but it's behind me because it's not a studio in here, it's just a home, so I got to do this all live here. So I'm just going to check out the chat here. Yeah, the free energy is just a syntax, but a lot of people, and they don't get it. Yeah, politics, stay away, stay away. So anyways, now that I have a few people here, what I was researching tonight was something very interesting. As the title states, I don't even know if I can pronounce it right. I think it's called Terfenol-D. And it's very interesting because it's an alloy, but a man-made mix of other. But altogether, when you have that alloy, you get a magnostrictive material, like one of the most ferocious responsive ever known. And it was actually developed in the 1970s by the Naval Laboratory in North America. So it was basically for military applications only, a little bit of aviations, and it was all U.S. Navy funded programs, actually. And basically it was named after terbium iron, Fe, and they mixed it with other stuff. There I have the, if you really want to know, it's TBXDY1 minus XFE2. That's the actual chemical composition of it. And you can look it up online and you can buy it. It's not restrictive, believe it or not. So I think it's very interesting to maybe order some of that. But it's easier to get in old Navy stuff. It's in old sonar heads. You could use that and essentially experiment with that because it's very responsive to external waves, vibrations, and all that kind of thing. So you could really use that for experiments as sensors as well. They use it for underwater as well. And what else can I find out about this stuff here? It's a solid state material, obviously, and it converts energy from one form to another, like piezoelectricity, but on steroids. This is like amazing. And the magnetostriction of the Terfenol-D generates strains 100 times greater than traditional magnetostrictive and 2 to 5 times greater than traditional piezoceramics. So you can see what this opens up as possibilities for exploring in unconventional energy systems if we were to build like capacitors with this stuff, right? And amateurs have been experimenting with this, and this is the kind of like cells they've been building. And here's another assembly here of some of these cells. And if you're going to notice, this starts looking a lot like the John Hutchinson kind of cells here. And I don't know if you can see that. But yeah, using this material to make piezoelectric or very more, what happens is there's the shape that changes drastically. So it's very, very ferocious. So we could build capacitor plates with this stuff, along with the solid state PEG electrolyte. What I'm getting at is we might be able to substitute the barium crystals, how do you call it? Titanate? Some words I have such a hard time with. But yeah, that stuff. The barium crystal like structure. So something I'm looking into, I looked it up on eBay, and there's a lot of old sonars, Navy sonars, a few of them, about $100 in the old surplus and junk stores on eBay. You'll find them there. So I've bookmarked several of the surplus collector people, and they actually have a few of these on eBay. So maybe next month, if it's still there, I'll maybe buy one and experiment with that. And essentially, oh yes, this one here, once taken apart, is really cool because it looks a lot like the Floyd device. You've got two bricks here that are made of this material, and you've got one coil on one side and the coil on the other side, and these two coils are what responds to it and connects back. You get AC essentially. So just putting it out there for transparency, whether it means good or not. I guess there's just one way to find out. Unfortunately, this stuff doesn't come cheap. So I'm thinking of just salvaging it out of the old sonars. There seems to be always one or two on eBay. For example, you probably want to look for, I don't know if I have it here. Do I have it here? Yeah, like there's something such as a sound bug device. Its first commercial application, Phoenix. Hold on. I'll just go check on my computer real quick. Here. Yes. So Feonic is the brand that you may get lucky with. And you can take this stuff apart. And it's also known as the sound bug device. So something fun to experiment with that could be highly piezo-like electric, but much more, it's like barium ferrite, but even more responsive. So let's see how everyone is doing. Yeah, 3D printer, of course. I mean, there's so many things on the list, but in the meantime, I like doing research, and it's writing notes, putting it out there, and stashing it away for a rainy day. But yeah, I mean, I don't need this, obviously. The PEG electrolyte and a good enclosure to separate the cells and put them in a nice series, perfect symmetry, because that matters with DC. As soon as you change the shape or capacity of any of the cells, your current rating just gets unbalanced. And when you're only dealing with milliamps to start with, you can't really afford to like lose 1.5, right? So by keeping it symmetrical, if you could at least keep that 2 milliamps, as we bring the potential up, that 2 milliamps means more at that potential, right? So you end up getting more watts out of it that way. So I think is crucial. The DC part of it anyways, the AC properties is a whole different layer, which I'm still studying, which I'm trying to find out which is the better way to take advantage of that interaction as well. So yeah, always something to think about, always something to do. So here we are. What else to talk about? Still cold here. It just got to like maybe 1 Fahrenheit, 1 Celsius, which is maybe like a little bit over 32 Fahrenheit. Just to say that the frost got off the snow. Hopefully it'll be back to normal. It's absolutely unseasonably cold. We actually had 70 there last week, and then it's back down to this. I don't like it. But enough about what I don't like. Um, I really am running out of things to say because I don't want to just repeat myself and start talking about, the heavy side component. I have plenty of videos of that. Um, there's the Bedini motor. What's the point of turning that on? We made about 20 videos of that. I guess we're going to call it quits for tonight. Just wanted to say hello. And this research about these sensors, which could be practical, maybe so, maybe not. It's out there. Take it or leave it, right? So with that said, folks, again, thank you for spending your time with me. And until next time, and have yourselves all a great day. Thank you.